Here, Dev, yet? No.
Testing 1 2 3.
Oh, okay.
Testing 1 2 3.
We're getting there.
Hello, 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 hello. Hello.
We got it.
Hello. Cool. Someone needs to enable screen sharing. Let me know. There we go. All right. Can everybody see this giant wormhole slide? It just says wormhole. All right. Okay. So I'm just going to assume that this works. Josh, if you could just send me a Slack message letting me know if this is showing, that'd be phenomenal. Perfect. All right. So I'll get started. So just a quick round of introduction. I am Dev. I'm very sorry I can't be there in person, but Wormhole has an offsite starting Saturday that we have to be there for. But I would love to be present during the hackathon on Discord for any and all questions that you might have. So I'm the developer advocate for Wormhole. You can find me on Discord, Twitter, Telegram. I'm Spaceman Dev everywhere that it matters. So what are we going to cover? We're going to cover, first of all, why would someone want to build cross-chain applications in the first place? What Wormhole is, some Wormhole key concepts, how it works, some applications. We're going to do some Q&A. And then if we have time, hopefully we can dive into some code and how to get started. I'm very excited about that. So first of all, why does someone want to build cross-chain in the first place? Why can't we just build applications on our favorite chain of choice? Well, if you look in the Web 2 world, we have various cloud infrastructure providers, right? You have like Google Cloud, you have Microsoft Azure, you have AWS. Imagine if you were filling out a mortgage application, but you couldn't connect your bank account because your mortgage application is on AWS and your bank account is on Microsoft Azure. That would be a terrible user experience. We have abstracted this away from the users in Web 2 by creating HTTP and inner infrastructure protocols, so the user doesn't have to care about what infrastructure the developer chooses to deploy on. They get to have a seamless, interoperable experience between all of these different applications. In the same way, when we look at Web3 apps, right now they might be small, and you only have small apps where you're interacting with just the app. But as the apps grow, as your ecosystems grow, as you're thinking bigger and bigger, we want to create better user experiences for most people. And then on the developer side, you might want to choose to go cross-chain because, despite what maxis say about one chain being the best or another chain being the best, the reality is for any given developer, there is a business, legal, and technical reason that they choose the infrastructure that they choose to deploy their chain. For example, I might not be able to deploy on Ethereum because a competitor is on Ethereum, or I might not be able to deploy on Solana because there are some liabilities on Solana that I can't take on. Like there's some legal reasons that I can't deploy there, or I might not be able to deploy on Gnosis chain because there are some technical reasons. So for a variety of business, legal, or technical issues, as a developer, I might choose one chain or another. And then I want to make sure all of my applications work together seamlessly because that's the best user experience. So what are the benefits of doing cross-chain development? I like to break it down into three major parts: liquidity, community, and identity. Liquidity is what we see most cross-chain applications using. So this is where you see most cross-chain assets going from chain to chain. For example, being able to trade Bitcoin on Ethereum, Ethereum on Solana, Solana on Algorand, moving liquidity back and forth so you're not tied to one chain. But the things that get me excited are community and identity. Not to say liquidity isn't cool, but there's so many people working in the liquidity cross-chain space. I'm very excited to see some more applications come out for community and identity. So with community, think of it like if I have an NFT project on Solana, like my Degen Apes, and I have a Bored Ape Yacht Club on Ethereum, maybe I want to create the UN of ape NFTs, right? I want to create an organization where all of these NFT projects can actually do cross-chain voting, where all of these NFT projects can vote. Like if I hold a Bored Ape Yacht Club, I can vote on Ethereum, and have that vote be counted towards this interchain organization. These kinds of community-based, like having a treasury on one chain, but being able to deploy it on various chains. And finally, identity. Identity is this concept of querying data about a user. So I gave the mortgage and bank account example earlier, but basically if I'm in an application, but my holdings are sitting somewhere else, or my reputation is on a different chain, I want to be able to bring that in and be able to say, look, I actually am a verified user on Twitter, or the Ethereum version of Twitter, and I would like to be verified on Solana in the same way. Or any number of different use cases. Gaming, if I want to carry my profile from chain to chain, and not just create thousands of different accounts. So for these three reasons and many more, a developer might choose to go cross-chain. So with that, let's talk about how, we talk about the why of cross-chain development. Let's talk about the how of cross-chain development. Now, generally, cross-chain development is done through using something called bridges, and we're talking about a specific bridge, in particular, Wormhole. So Wormhole is a fully generic cross-chain messaging protocol that connects multiple chains. I think we have something like 9 or 10 chains right now, with our goal of being like 17 chains by the end of the year. But beyond the number of chains that we connect, one of the really cool, and I should add Algorand here, one of the really cool things that we are working on are connecting different ecosystems. So not just all the EVM ecosystems, which you might see other competitor bridges do, but expanding out to more exotic ecosystems like Solana, CosmWasm, Algorand, etc. And unlike certain other bridges, we're not just about moving liquidity around. We're not just about moving tokens from one chain to another. It's about actually sending messages from one chain to another. And when we can define the message as any kind of bytes payload, we can put whatever kind of data that we want in there and transfer it. So how does Wormhole work? Firstly, we have this concept of the core layer contracts. There's a contract on every chain that we connect to that can publish messages, verify messages, and execute governance. Then we have our Guardian nodes. So we have a set of 19 Guardian validators that listen. These validators run a copy of every, they run a full node for every chain that we connect to, and they listen to that core bridge contract every time it emits a message and says, hey, I'm creating a message. They pick it up and they sign it and they store it. And then this message is called a VAA. You might hear this when we're talking about Wormhole. It's called a verifiable action approval. It's we can get into the during the Q&A about how this actually works, but basically this is a Wormhole message. It stays with the Guardians until something called the relayer comes around, picks it up from the Guardians, and submits it onto the target chain. This is because submitting a message onto the target chain costs gas, so the Guardians are not incentivized to submit it themselves. So you need some kind of third party, usually your own app. So normally, like if I'm building a front-end app and my user does an action, I'll just wait until the Guardians have signed the message and then go ahead and submit that message onto the target chain on their behalf. Cool. Next, let's talk about some applications that have been built on top of Wormhole. So the first, one of the biggest applications that we usually talk about is the portal token bridge. Most of the people that want to build on Wormhole are thinking about building on Portal. And Portal basically allows you to lock up funds on one chain and mint wrapped versions of the asset on another chain. It's a custody and mint token bridge application. Within Portal, we have 3 defined payloads. One is just moving, I would like to lock up currency on one chain and then mint the same amount on the other chain. The second is actually giving information about what that token is. And then payload 3, which we're very excited about, is something called contract controlled transfers. And what that means is not only can I send tokens from one chain to another, but I can attach data to that token message. And so I can say, for example, here, have 5 tokens, but also can you do XYZ thing with it? For example, can you swap that token when you receive it on the target chain? So I'm actually sending you Sol, but I want Algo on Algorand, and so on. and make that as a seamless atomic transaction. Xanchor, RIP. So when Terra was alive, they had this Avalanche to Terra bridge. Anchor was a massive yield farming a loan application. Basically, you could deposit funds into Avalanche and get that transferred over to Terra automatically. And they used a mixture of Portal and Core Layer to get this. And then Pit. Pit is a huge project. Pit submits Oracle data for price feeds for various assets like Bitcoin, Ethereum, a bunch of crypto assets. It publishes price feeds directly into Solana, then creates those as VAAs, messages, and then goes ahead and allows anyone to submit those on the target chains. For example, you could get this price data available in Algorand, price data available in Gnosis chain, or not Gnosis chain because we don't support that yet. But you can get on CeeLo, on Near, wherever you want to have this price data available, even though Pit is depositing into Solana. All right, I want to stop there before we go any further and just take a moment to answer any questions. So I can answer questions on Discord, or I can answer questions if there's a mic in that room, however that works out. No questions, or are we walking towards the mic? Okay, I've just been told to carry on. So next, we will go into some code on how to actually get. If you can't figure out how to unmute, Josh, you can just have people type questions into Discord, and I can answer them there. So like, if you just go to Hackathon, like general or Hackathon schedule, and I'm happy to answer any questions there. Okay. While you guys think of those questions, let me go ahead and move along to some code. So one of the first things that you're going to do if you want to develop, and this is not just about developing on Wormhole, if you want to build a cross-chain app, you want to deploy to various chains, you're going to get set up with something called a tilt environment. I will actually post all of the docs on how to get started. I'm actually working on them as we speak. But one of the things you're going to do is set up a tilt environment, and it's going to look something like this. This is, you can set it up in a VM, you can set it up on your own machine. Although if you're working on Solana and you have an M1 Mac, this might not work. But basically what this runs is a small devnet for Wormhole. It has one of our guardians along with 2 Ethereum chains, an Algorand chain, a Solana chain, a Terra chain. Yeah, and so most of the EVM chains you can just use the ETH chains to go ahead and use. But basically, when you create a cross-chain application, you're going to take this endpoint as the RPC and deploy code to it. So I'm going to get into that code. I'm going to get into that scaffold in just a bit. But the first thing that I wanted to get you familiar with is the concept of the Wormhole Devnet. And the Wormhole Devnet basically is this, Dockerized multi-Kubernetes, multi-validator network that you can play around with. And if you don't want to use this and you want to deploy to somewhere else, you want to deploy to testnet, you can do that too. If you want to deploy to mainnet, you can do that too. This is just so if you're writing contracts, you can do quick iteration. Now, I have to mention, if you're just doing token transfers, which is just moving tokens from one chain to another, and you actually don't need to write your own contracts, you might not even need the devnet because we have a JavaScript SDK that lets you do all of those token transfer stuff entirely in JavaScript. So if you're thinking about just doing token transfers, like you just have a front-end application, you want to take in deposits into your application, that's a pretty easy use case and you don't have to write any smart contracts for that. Okay. let me switch to some code. Cool. So I will share this repository with you guys. This is the Xdap book. It is on GitHub, Certus1 Xdap book. I'll share it with you guys. It's not built yet, which is one of the reasons I haven't publicly shared it. Yes, I will zoom in. But I will just walk through this repository because as you get started, this will have all of the information that you want. Under source, you'll have a bunch of documentation. Right now, there isn't anything because I have to copy it in. You can also find our docs at docs.wormholenetwork.com, but I'm migrating them over to this book. But the more interesting thing here is under projects, you'll have a starter messenger project. And the messenger project is a great scaffold for what a cross-chain application looks like. So I'll zoom in a little bit more and we'll just walk through this setup. Basically, we have a folder that's our cross-chain app messenger. Inside of it, we have a chains folder. In the chains folder, we use, if you know what NPM workspaces are, NPM workspaces basically allow us to set up packages within one NPM directory. If you have questions about that, feel free to ask me. I'm happy to help you set that up. It's very simple. It basically is in your package.json in your root. You just have this workspaces, and then you point to each individual workspace. And then for each workspace, for example, EVM, I have set up EVM using Foundry. Foundry is a scaffolding tool for EVM. And for Algorand, I just wrote the the messenger.py. Well, Josh wrote messenger.py. I just copied it and took all the credit. But you can basically take your folders for each chain that you want to develop on. You can use the application framework that you want to use with that tooling. For example, if I wanted to write Solana, I could do Anchor in it. Anchor is a scaffolding tool for Solana, and make a new folder here for Solana. So Algorand, EVM, Solana, whatever chains that I want to develop on. And then I basically just write my code, right? So like for EVM, I have, we'll go through this code in just a second, but I want to walk you through the files first. Like my Sol contract. For Algorand, we have the Algorand contract and deployment and so on. So we'll come back to this in just a second and walk through all of this. Next, I want to take you to xdap.config.json. You won't have one that's filled out. You'll have an example.xdap. It'll look like this. It'll be kind of empty, but it's fairly easy to fill it out. Basically, you define the networks and some wormhole constants. You're going to put your RPC nodes here. So if you want to deploy to the Tilt environment, the Tilt environment is going to be hosted on some RPC or some IP address. You're going to put that IP address in for H0. The port is 8545. You can find that out by going to the Tilt environment. And in the top left, I was trying to see if I still had it open. Oh, but it won't let me share more than one screen. It'll be posted. The ports will be posted basically when you click on each pod. So 8545 for ETH, 8546 for ETH1. Algorand is going to be on port 401. The stuff looks a little different in each of these networks because of how they consume it. And we'll talk about that when we look at the code. You can put your mnemonic. You don't have to worry about certain things like deployed address and emitted VAs. You can leave those blank. These fields are populated from the code when it deploys the code. So you'll just have to fill out this stuff: type, wormhole chain ID, RPC, port, mnemonic, bridge address. And again, because these docs are still a work in progress, any questions you have as you're getting started with any of this, please tag me in Discord. I'll be here. I'll be happy to hop in and help you get all of this set up. Next, let's take a look at messenger.js. This is our orchestration. This is our orchestration JavaScript file, and it is in charge of deploying to various chains, taking our code and deploying to those chains, and then running our 4 basic functions on each of those chains. So the basic messenger contract, all it does is send a message from any given contract to any other contract. And to do that, we need to break it down. And let's look at the EVM example because it's just the easiest to read. But the way we can do that is we need 4 functions. The first function is send message, which will take some string and publish it. Second function is receive encoded message that will take in a wormhole message, decode it, run through some checks, and we'll talk about all of those checks when we get a little bit into the code. The third function is get current message, and all that does is print the current message. And the fourth function is register emitter addresses or register application contracts. This is kind of optional, but basically one of the checks that we do is when a message is submitted into our contract, into the target chain, into the receiving chain, we want to make sure that the message was emitted from a chain that we actually, from a contract that we actually want to listen to. So for example, if on Solana, you have Dev's Apple Shop and Josh's Apple Shop, and on Algorand, you have Ryan's Bakery. Ryan's Bakery might only want to accept messages from Dev's Apple Shop and not Josh's Apple Shop. So he wants to make sure that he registers Dev's Apple Shop, and that way any message that comes in from Josh's gets ignored and discarded. Hopefully all of this is making sense. Like I said, any questions, please just feel free to write those in Discord. I'll go over those just after I've gone through the code. Okay, so we covered that. We covered the 4 functions. Let's take a look at messenger.js. So you'll have, again, this working example that you can play around with. And actually, before we check out messenger.js, let's check out a test. So basically, the way messenger.js works is that we can call it by saying node messenger.js, just like we would call any messenger or any node file, and then passing in arguments. And the arguments work like this. You pass in the chain that you want to interact with, the function that you want to call. So for example, if I want to deploy ETH0, I just say, please deploy ETH0. If I want to deploy ETH1, I call deploy ETH1. Then we talk about registering chains. Again, this is about registering the deployed chain on the on our counter chain, or deployed contract on the counter chain onto our chain, and then sending messages, submitting BAAs. You can do latest. Basically, it means just the most recent one, or you can pass in the number, which will be a previous sequence. And we'll show you how all of this works in just a second. And then normally after submitting a BAA, you want to sleep just for a couple seconds so the state gets updated before you fetch the current message. So you can see, like, you can basically interact with this almost like a CLI tool, and you can play around with it. This is an ETH0 to ETH1 test, but I could just as easily have written a test that did ETH0 to Algorand, right? There's like one function missing in Algorand that I wasn't able to complete in time, but by the time you guys get this repository, it'll be complete, and then you'll be able to see it. Cool. I will leave it to Josh to explain the Algorand code. I don't know if Josh or Ryan, do you want to go up and explain this code right now, or should we go to questions? Just giving it a second. Okay, I'll give you guys a second to figure out how to unmute the mic. In the meantime, let me check Discord to see if there are any questions in Discord. Looks like no questions in Discord. But yeah. Messenger.js, basically, yeah, whenever you add in a new, when you get this, you'll also have the Solana folder. So the EVM folder will let you deploy to, like if you want to go deploy, you'll have access to any and all EVM chains. That's like Near on Aurora. You'll have Ethereum, Polygon, Celo, etc. and then Solana and Algorand for the Solana and Algorand chains. And if you want to get started with those chains, like especially with, I know that some of this is a little bit trickier on Solana and Algorand, please reach out and ask for help.
I think we've actually figured out how to unmute things.
Nice.
So I guess I have any questions. Are there going to be questions on if you want to go through the Algorand side, or if you want to sort of keep going?
I want you to go through
Of course, you would love to go through the Algorand side. Yeah, of course, I'm going to have him sort of scroll all the way down. Obviously, so Algorand is sort of actually very similar. We have scroll all the way down to the bottom. You have a transaction that you can use.
I actually don't see the Algorand directory. Is this on like a different branch?
Yes, it is. Let me push that right now. You guys caught me.
It's like any standard hackathon. Literally, he said, okay, let's see if we can get Algorand into this like today. So I got up like at the crack of dawn and started writing contract code for Algorand.
All right, it'll be in the main branch now.
Yeah, this is, so again, one of the interesting, if what we've done with the Tilt environment here is that we've got sort of a static wallet that we sort of always fund, so you can write your example code. So again, this deploy thing here is just deploying a simple contract that we've written using the Algorand Python SDK in this particular case, where we compile it and then we have a transaction, and at the bottom we send it some money. And you can actually scroll up to, there's a send message within Algorand to sort of see, keep going up to send message. Keep going up. So if, for example, keep down, was that like line 107. If you, for example, you have an Algorand application and you want to send a message that is attestable. Okay, so the idea here is, you create an action on one chain, you want to be able to sort of attest for that and be able to go to another chain and see it. You can see how relatively, there's not a lot of code involved. Send message goes from line 107 to 123, and all it is just a cross contract call to the core bridge. That's really all that's required to get this message. So you basically call a message on the core contract to the public message, you pass anything you want, and that core contract then tags a sequence number on it, which you then are handed back. You're handed back a sequence number within the Algorand logs, and you can then go out to the guardians and say, give me the VAA for this particular message, which you then can go to another contract, another chain, and apply that VAA into sort of the receive side. And so if we scroll down on the other side, we can actually look at receive message. So that was down, yeah, stop there. Yeah, go up. So on the receive side, it's sort of very similar. It's, we're receiving this large blob and we have to validate it. We have to validate, basically walk our way through the raw payload, the bytes. And so that's unfortunately what we're doing here, like at line 142, where I'm walking through the signatures. But the assumption is within my code that an earlier transaction has already validated this. It's this verified VAA that you see at like line 164 says that an earlier transaction, my transaction group in Algorand, has already validated that this payload was in fact legitimate, that it was signed by the 19 guardians. We've gone through all the governance that's required. So this is real data. So you should be able to count on that. So if I were to, if I'm doing like a token bridge transfer, obviously, your code would then go, okay, let me mint the coins. Let me give them the coins on the other side. If I'm doing an NFT transfer, the NFT would then say, okay, the NFT is locked up on the source chain. I now can mint it on the destination chain, given the information. So if we scroll a bit further down, like to line 181, we're sort of past all the boilerplate, and all I'm basically doing at like line 187 is I'm just sort of logging the payload that came in. But at that point, you can begin to parse the data and do anything you want with it yourself. So in this case, I send hello world from one chain, and it shows up in the logs on the other chain. But you can just sort of build out yourself that way in Algorand. If there's and on this messaging layer, we've built our own apps. We've built, it said, the PIF attestation. We've built, a token. We've built what we call Portal, which is moving tokens around, NFTs for moving NFTs around, and there's a lot of other people developing upon this messaging layer. But this is a great place to start. These simple cut paste examples, because you can sort of build it out yourself. Any questions? Let him go on. Back to you, Dev.
Yeah. One thing, I can also show some Solana code. The Solana code is a lot more of a mess, so I apologize. But I will have a much cleaner version of Solana code up in a second. I gotta just copy it over. Let's open that up. So if you're looking at Solana, Solana's programs are going to be much bigger, but basically it works kind of similar to Algorand, where you first have to send message, you pay the fee, send the message. I'm using, I know that one of the Solana talks that you guys had, they showed you how to do bare Solana. If this is confusing to you, I'm actually using Anchor, which is a much simplified version of Solana. Well, not simplified, but it's a meta language on top of Solana, which is a lot nicer to use. I'm happy to do an introduction course on that as well. But basically, it means that if I go to like my accounts, I have an account constraint language. It's just it's easier for me to read this code. So I'll have this as the anchor code in the Xdap book repo, like within an hour or so. So you'll have both Algorand, EVM, and Solana messages going back and forth. And then if you wanted to initialize the Solana messenger, that's how you would do it. You're going to register an ETH chain. You want to send a message. These are the JavaScript functions that you would call. I'm not going too deep into them, but basically in Solana, you have to like gather all the data, all the accounts that you want to access before you actually get to access them, which is a pain and a half, which is why most people like write in not Solana. But if you are interested in Solana, it's a good chain. We can show you how to do that as well. So that's the code examples. You should have a working messenger out of the box at the Xdap book. Talked about why someone might want to build cross-chain, talked about the tilt environment. I don't think I have anything else. There are no other questions. I think we'll call it that. You guys figure out if you want to unmute the mic or not.
Okay, I've got it unmuted. All right, so let me look out at the audience here and ask, does anybody have any questions for Deb or the examples that you saw? Would you want him to go back and zoom in on anything or rehash any of what you've seen thus far?
Or would you like us to build any more samples like today that you guys can cut based on your projects? Well, what would you like us to focus on?
Maybe what
you should message us.
Yeah, what chains are you working on? Okay, so I represent Algorand. So who's working on Algorand? Let me see hands. Okay, great. Yay! We got half the room. All right, who's working on Solana? And anybody working on Ethereum? Great, we got a couple here. Who else is next? What else you got demos for?
EVM, Ethereum is Polygon, CeeLo. Polygon, CeeLo, Ethereum, and then I forget the fourth chain. Oh, Aurora on Near.
Okay, great. We're Near. Anybody on Near? Didn't see any hands for.
Well, I think Near is just fully missing the bridge from Binance.
All right. So the question is about: is there a bridge between Binance and Near?
Yes.
Oh, yes. Yeah, we do have Binance Smart Chain as well.
Yeah, there's Binance Smart Chain, and right now there's the Aurora EVM layer on Near, and we're actively working on database. So right now you bridge on Aurora back to the native and stuff. Working on it. We have the messaging layer already done for native here. We just don't have the tokens.
Okay. Any additional questions anybody else has? All right, so no more questions in here. So Deb, you're coming back tomorrow as well, half an hour earlier. And what are you gonna show for us then?
I think we're going to try to do a portal example, if people want to see that, which is basically moving tokens. So we did a messenger example, and hopefully by tomorrow we'll have a token example.
So
If there's interest in that.
With that token example, we're going to also hopefully do what we call payload 3, which is direct messages into contracts on target chains with money and data. So if you want to execute and only have that message be executable by a target contract, you can actually set up contracts to do that. With guarantees, the only target contract can receive money and execute it, it's notified them. So you can use that for funding smart contracts. If you want to deposit, if you want to deposit something as part of your cross-chain swaps. Yeah, hopefully. Yeah, we have the demos working.
I have a question. Because you need to use the payload tree transaction if you want, every time you want to send tokens to a contract, or only when you want to send the tokens and some other information.
The payload 3 is the only one right now that guarantees that contract has to be involved for that PAA to be redeemed.
Yeah.
So if I were to do a standard transfer, I could do a standard transfer to a contract, for example, an Algorand. I can just put the address of the contract in Algorand, but there's no guarantee that contract will be notified that that money has come in. Where payload 3, Wormhole actually guarantees that contract is actually notified and given a message when that message comes in. And gives you the opportunity to reject the message in your own contract. Where if you just use a standard transfer, the money's handed to you, and maybe you can reject it or not, but now you have a problem to deal with. And you may or may not be notified.
Yeah, great questions. Dev, can you put up on your screen where your code is at so that we can download it? And do you have a slide like how do we get a hold of you? Where do we reach you? Obviously, we know for sure that in this Discord server, so for the hackathon server, there is a Wormhole channel. There's an Algorand channel. There's a channel for all of the protocols, right? And all of the sponsors here. So if you have a Wormhole specific question, ask it in that channel. And if you have one for any of the other sides, ask them in that channel as well.
And we will, receive questions, suggestions in that Wormhole channel. We will try to see if we can put it together next day or two. So let people have this. That's sort of why we're here.
Yeah, so I just dropped the Xdap, the messenger example that I was going over in the Wormhole channel. And then, best place to just reach out is on Discord. We have a Wormhole Discord as well. Whichever Discord that you prefer, that would be the best.
Perfect. All right. So again, for the recording, everybody make sure that you're checking out the Activate Wormhole Discord channel and look for the link in there for the code. Perfect. All right. Any other questions before we wrap up? All right. Thanks again for your time. We'll see you tomorrow, Dev. Take care.
See ya.
All right. I have absolutely no idea how to turn this off. So.